Very good morning to all of you. And hope all of you have a good health in the COVID-19 situation. I am Devasis Das, and I will going to for discussing about our paper titled "Design of a Secure Blockchain Smart Internet of Vehicle Architectures." It is basically for a blockchain application for the domain of Internet of Vehicle. I am going to discuss about paper introduction, so what is blockchain technology and security issues in Internet of Vehicle uh, architectures and blockchain-based smart Internet of Vehicle architecture, performance analysis of the paper and conclusions and future work also. Finally, I will discuss. Blockchain is a decentralized computational information sharing platform where multiple authorities domain can connected and communicate with rational decision making process. And blockchain has a distributed database with strong consistency support, and it is basically immutable ledger have been occurred and securely stored the data in it. Blockchain can improve the way of new communication between vehicles to vehicles or smart internet of vehicle architecture. It is actually worked more as in vehicle management policies. Blockchain technology is nothing but an open distributed ledger where each and every entity connected in the blockchain network can share data within a span of time, and it can also provide the transparency of the data. It is also efficient and verifiable. Everyone can check and validate the data stored in it. Blockchain stored data permanently. No one can modify or alter or delete the blockchain's data. The existing security issues in the Internet of Vehicles is internal device security, service platform security, data security, vehicle to vehicle communication, or everything connected vehicle security also exists there. Like intelligent device security means device data can be hacked using IoT, where blockchain can improve this problem. Blockchain based smart internet of vehicle architecture. It is a decentralized, secure and transparent conceptual framework where multiple authorities like authenticated entity can connect it with the blockchain network and validate the vehicle related information as well as many services. It can provide a decentralized way of communication between vehicle-related authorities, where multiple authorities can securely achieve the data stored in it. Vehicle authorities are connected through the block to provide the blockchain-based smart Internet of Vehicle architecture framework. It is also a V2X communication framework where multiple vehicles can communicate with each other using blockchain technologies. Its features. This is the proposed architecture where we have selected vehicle certification agency, vehicle insurance organization, RTO office, and motor vehicles office, or police headquarters, etc. We are selected these for entities of the proposed architecture, and there have also zonal office where vehicle can communicate with their own zonal office, and this and stored vehicles details like vehicle owner details, vehicle details stored in the zonal office, and zonal office can communicate with parent zonal office. Therefore, the data can be shared all the connected entities. The proposed attributes of the blockchain-based smart IoV architecture: universal vehicle key. Universal vehicle key can identify a vehicle as well as the vehicle owners. It can using UV key we can easily retrieve the vehicle details as well as vehicle owner details. It is designed using public and private key features, and it can also it can generated using smart contract automatically. No one can modify or assume the UA key, so it can be secured. Thus, we use the UA key. Vehicle intelligent device can communicate with the blockchain's applications. It can synchronize the data with the vehicles as well as blockchains applications. And VID can store data temporarily, and therefore the data can be sent to the blockchain ledger as well as vice versa. And VID can send an automatic message to the vehicle authorities for any issues happened. Entities of the blockchain-based smart IoV architecture, vehicle authorities website. I previously said vehicle transport agency, regional transport office, traffic management authority can access the vehicle's details, and thus they are main entities of the proposed work. And there are thereafter emergency service station like police station, hospital, and fire station, etc. Take necessary step to provide the required services for the vehicles. Message propagation procedure. BID can send messages to the emergency service station whenever it is required. The message includes vehicle ID and timestamp value and the message content of the message. So when vehicles have some issues, VID can send the message to the emergency service station for the required emergency services. The VID can placed in the vehicle and it can be used for the message propagation procedure. This is the message propagation procedure framework, where vehicles can send to the emergency service stations messages using UV key, and this UV key connected from the zonal office ESSS emergency service station like police station can receive the UV key from the zonal office where previously stored the UV key, and therefore the received UV key and stored UV key they can match, and they can match the UV key, and therefore they can take necessary steps for the future solves. What is the secure data communication procedure? Vehicle authorities and parent zonal officer connected through the blockchain network, one blockchain network, and zonal offices and emergency services connected to the another blockchain module to enhance the bandwidth, communication bandwidth, etc. Thus, we have selected two blockchain network, but common connected entities are here: parent zonal offices, and all zonal offices is connected to another blockchain network. So thereafter, messages can be synchronized with each other easily with good communications bandwidth. And vehicle authorities can access all zonal offices data through the parent zonal office, and the communication data can be sent and received using encryption and decryption procedure, you basically using cryptography, so there have no chance to modify or delete any data. And ESS can be identify the vehicle using UV key, where vehicle stolen or accident has happened, and then thereafter emergency service station can easily send the message to the owner as well as the parent zonal offices. This is the secure data communication procedure where everyone can validate the information, request for validations, and police stations. Also, here emergency ambulance services has existed. Vehicle can identify, uh, vehicle can send the message. All connected entities using message fetching procedure, using VID, using UVK, So all the features are here included for the secure smart internet of vehicle architecture. Blockchain-based smart internet of vehicle architecture actually used or presented or proposed for providing smart internet of vehicle services in the domain of smart internet of vehicle, and it can provide a decentralized communication between regulatory authorities to, and it is also used to overcome few existing issues like data manipulation, like user privacy, like some data security, etc. And this framework can enhance these issues. It can share information within a short period of time and provide accurate services for the vehicles. Thus, blockchain as a blockchain is a low risk technology and have transparent database, so we can use blockchain for the Internet of Vehicle architecture, and it can provide also secure, decentralized, and open communication platform to connected different associated authorities, different authorities for the associated proposed framework, and it can provide the better vehicle management policy, vehicle security and safety, data security also, also services uses can services, vehicle security and safety, data security and efficient services can be using these emergency service station to achieve the smart internet of vehicle architectures. And in future we can be expanded the smart internet of smart contract features to as applications, and we can extend the smart contract data, proposed design smart contract, and therefore we can establish the vehicle to vehicle communication procedure, how vehicle to vehicle can communicate with blockchain technology to reduce the risk of vehicle accident in future. There are some reference we have used in our paper, and thank you so much and have a nice day.